Coral reefs are underwater ecosystems characterized by the presence of coral formations, which are colonies of tiny, interconnected organisms known as coral polyps. These reefs are typically found in shallow, warm waters and are renowned for their biodiversity and vibrant colors. The skeletons of coral polyps create intricate structures that provide habitat and sustenance for a diverse array of marine life, making coral reefs vital for the health of ocean ecosystems. They are often referred to as the rainforests of the sea due to their richness in marine species and ecological importance. Appreciating mathematics in coral reefs involves delving into the fascinating intricacies of their structures and the underlying mathematical principles that contribute to their beauty and functionality. One prominent aspect is the geometric position evident in the growth patterns of coral colonies and the intricate branching of symmetry observed in coral formations often adhere to mathematical principles, creating visually stunning and harmonious structures. Furthermore, the concept of optimal packing is integral to the growth of coral skeletons. Coral polyps exoskeletons to maximize the use of available space while maintaining structural integrity. This optimal packing not only ensures the stability of individual coral structures but also contributes to the overall resilience of coral reefs as ecosystems. Beyond geometry, mathematical models are employed to understand the intricate ecological dynamics within coral reefs. The diversity of species, their interactions, and the delicate balance of the ecosystem can be modeled using mathematical concepts. This includes exploring the relationships between different coral species, the impact of environmental factors, and the interconnected of life within the reef. The Fibonacci sequence, a mathematical pattern where each number is the sum of the two preceding ones, can also be observed in certain aspects of coral growth. While not universally present, some coral colonies exhibit spirals and patterns that align with the Fibonacci sequence, adding another layer of mathematical intrigue to their formations. In essence, appreciating in coral reefs unveils a deeper understanding of the underlying order and complexity that contribute to the resilience and beauty of these underwater ecosystems. It highlights the profound connection between the precision of mathematical principles and the dynamic, ever-changing world of coral reefs, enriching our appreciation for the intricate tapestry of the natural world.